Hello. So I'm well aware that it's 3 p.m. on a Saturday, and this is what biologists call the circadian dead zone, aka nap time. So I've tried to make this presentation as vibrant as possible because if we're honest, observability isn't everyone's favorite topic. But welcome to open source, developer-friendly observability in only a few lines of code. Today, we're going to enhance production code with metrics, objectives, and alerts, and there's going to be a lot of generative AI of animals, which will make more sense in a little bit, I promise, but for now, trust the groovy panda. We are going to use two tools that rely on open source and open standards. Those tools are Prometheus, which is an open source time series database that's really well known for being associated with Kubernetes. If you're like me, you've probably heard of Prometheus, and you don't really know what it does. At least that was me until about a year ago. But we're going to clear that up today. And then on top of Prometheus, we're going to use a Python library called autometrics. This is a small framework that quickly adds function-level metrics to your code and does a lot of developer-friendly goodness along the way. Essentially, it eases the pain of working with Prometheus for developers. I have some disclaimers because I don't want to lie to you. The title of the talk said only a few lines of code, and in actuality, it means only a few lines of code if you have Prometheus up and running. So just to be totally clear, there's some other things at play here, but I will show you ways to get it up and running easily and locally by the end of the talk. Okay, you might be wondering, why are we doing this? And that's a great question. It's good to ask questions. I'm glad that you asked that question. I have some answers. And the first is that it's really good to have a goal. When you release software into the wild, you should target some level of reliability, availability, things like that. And once we have a goal, we can strive for it. We can know whether or not we're meeting it. So it's good to have a goal. Secondly, reliability is a feature, like it or not. When we put our software out there, people expect it to work. And a lot of times, it's easy to kind of put that on the back burner when we're working on the feature itself. So metrics and observability are a way of ensuring that our software is reliable. And finally, you can try this at home. Because this is all open source, you can quickly run it locally, try it out. There's no concept of vendor lock-in here, and it's fun to play with. So a little bit about myself. Oh my gosh. My name is Brett, but my nickname is Boots. You can call me @Boots in Discord. I am actually, I'm a front-end lead, so I mainly write TypeScript, but I help maintain the autometrics Python library. I take a lot of photos in my spare time, which is somewhat ironic because I didn't really learn how to pose like a normal human being in photographs, which is why you see this before you. I am usually based in Amsterdam, but I grew up in the United States. About 6 years ago, I fell in love with stroopwafels, also known as stroopwafels, which are a delicious Dutch delicacy of two very thin waffle with caramel in between it. And if I apologize deeply. I was going to bring a bunch to like hand out at the conference, but I totally forgot. So talk to me afterwards. If you've never had one, I will gladly mail you some. Final note here is that I like animals and generative art. You already saw a funky panda, but this will be relevant in a couple of seconds, meaning right now. I'd really appreciate it if you could check out my app. I've been working really hard on it. It's called animalbuttons.biz. It's the word animal and buttons put together, then .biz, like business, but spelt really cool. I have a QR code. Basically, this is filling a niche that I saw. Like, I was on the internet, and I was like, there's no website with a button of an animal on it, and then you press that button, and then you see the animal. So I just went ahead and built it, you know? And, you know, they say it's better to show than tell, so I'll give you a look-see. This is the UI. It's for animal. I designed it myself. And you can see there's a rabbit button, and when you click it, a rabbit shows up, like, really quickly, because rabbits are fast. And you can just go to this website, you can click it as many times as possible, and it'll help the demo. And you can just click it as much as you want. And then also there's a panda button. Oh, there's a panda button. There's a panda button. There we go. Okay, there's a panda. I've been getting some complaints lately about the panda, but maybe we can look into that a bit. So yeah, that's my website, animalbuttons.biz. I'd just appreciate it if you could give it just a little look-see. But I built animal buttons with a Python fast API backend. The architecture is profoundly simple. Anytime that you click on the rabbit button, it calls a rabbit API that returns a rabbit. And anytime that you click on a panda button, it calls a panda API, which returns a panda. Very, very easy to fit in our heads. Now, the problem is people keep telling me that the panda has issues. Like, sometimes it doesn't work. We just saw that. But also, they've told me like it's been kind of slow since the latest update. And so these are good things to hear from my users of animalbuttons.biz, but they're not very actionable. Metrics are a tool that can help us quantify the panda experience. Not the experience of the panda itself, but of the user experience of someone clicking a panda button. And actually, wait, real quick. So I just found this kind of funny. This illustration right here, I asked for a panda that did not work a lot and was kind of slow, and the AI gave me a panda with red eyes. I'll let you imagine why. OK, but before we dive into metrics and how to use them, I think it's useful to settle on a couple of concepts. None of these are terribly complex. It's just good to know, like, when I speak words, what do those words mean? And then we can all agree on those, and then we can understand things. So we will talk about observability, metrics, alerts, and objectives. Let's start with observability. To me, simplest definition here is how do we know what's actually happening when a program runs? And if you watch any talk on observability, you will see a slide with 3 pillars, with those pillars being logs, metrics, and traces. And it's considered that if you have logs, metrics, and traces, your system is observable. I find this illustration of pillars insanely boring, so I reimagined them as 3 caterpillars. On the right, you will see the traces caterpillar, who is wearing sunglasses, even though we're inside, because traces are for cool kids. They are relatively complex to set up. They can be very useful, but they're out of scope for this talk, so we're not going to talk about traces. On the left, you'll see our logs caterpillar, conveniently shaped like an L. And this is the pillar of observability, or caterpillar of observability, that we all know and love. This is our print statement. This is our console.log. This is the thing that we put it in our code, and when we can know later if that point of code was reached. They're excellent for debugging. They're like a snapshot of state for us to inspect if something goes wrong. However, they don't scale very well. If you've tried to debug only using logs in production and you don't know exactly where your problem is, you are stuck sifting through a lot of data, your queries take a long time, and that is where metrics come in. This smiling green friend I like to call our goal-oriented caterpillar. And that's because metrics see the forest instead of the trees. They're like a summary statistic. So whereas the logging caterpillar is like, this happened, this happened, this happened, this happened, the metrics caterpillar will tell you, this happened 5 times. Some examples of metrics for the panda. You can see our panda there with 2 little metrics caterpillars on his shoulders. One would be the error rate. This is considered one of the golden signals. And a 10% error rate would mean that 10% of requests to the Panda API have failed. OK, so I had that complaint earlier that, like, sometimes the panda's not working. This puts a number on it. And it's worth noting that, yes, the Panda API may have kind of failed miserably, but also adorably. On the right-hand side, you'll see percentile of latency. So this is also considered a golden signal, the latency, i.e. how long something took to complete. And when we talk about something like the 99th percentile of latency, that would mean that 99% of requests to the Panda API finished within, say, 500 milliseconds, so half a second. And the reason that we use a high percentile of latency is it allows us to quantify the tail end of a user's experience. So I had that complaint, right? Since the last update, it's slow sometimes. So this, using a percentile or a high quantile, lets us look at, OK, for the majority of users, it's under this amount. But when you go past that, maybe it's getting kind of slow. OK, so we understand what metrics look like. Just to drive home their value, they are useful because they show the big picture and help you identify trends over time. They're cheap because they require less storage and bandwidth than logging. But however, there's a catch. They're kind of expensive because they have a learning curve. They require maintenance or special tools to set up, like Prometheus. And if you go to a managed service provider, a lot of them are more than happy to charge you many, 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 many dollars in order to set up your observability posture. There's a famous story of Coinbase paid a $65 million bill to Datadog the other year. And that's kind of what happens when you let your observability go out of control and don't really care how you're storing data, just as a lesson to us all. Now, alerts. To me, an alert, I mean, this is intuitive, right? An alert is just like, hey, something seems off. To me, it's that seems part, right? Like, maybe it's not off, maybe it is. Either way, you probably want to know. So in this case, maybe the error rate spiked all of a sudden. Or maybe it's been slowly increasing over time, which is a lot more difficult to catch. At any rate, you want to know. You want a heads up. And also worth noting here is that alerts are really part art and part science. You will almost always need to tune them a tiny bit to your organization's needs. But if you have well-instrumented code, if you have metrics, it makes that a lot easier. Finally, objectives. So to me, an objective is a measurable goal that enables effective alerts. So a measurable goal is something like, hey, animalbuttons.biz, all of those API routes should work 99% of the time. And an effective alert in this case allows us to get concrete about like what do we mean when we say a spike in errors. So in this case, one guidance from a Google SRE handbook is that if the error rate exceeds 14% within a 5-minute interval, send me an alert. Okay, so now we kind of have a way of reasoning about how we should be alerted and our goals. We know a bit about observability, about metrics, alerts, and objectives, so let's talk about the tools. Like I said, Prometheus is effectively a database, but it also exposes querying logic for you to be able to interact with metrics. And autometrics is basically something that makes it easier to interact with Prometheus. Pictured here is Prometheus trying to set up Prometheus. If you've tried to do this on your own and you are not a DevOps or an SRE, it's kind of hard sometimes. Actually, this is kind of legible. I tried to make a bullet list that would be illegible to everyone, but the screen is much bigger than I thought it would be, to drive home the point that there are so many things to consider when you're setting up a metric solution. You have to provision and tune your infrastructure for the database. Then you need to decide on what metrics you want to measure. And then probably the most complicated thing for most teams to agree on is what do you name them? We've heard that a lot. I work in an observability company, and we've heard that a lot from teams implementing them, is people have opinions on how you should name things. Novel. Finally, once you have a consensus on how you should name things, you have to add the code to your application to generate said metrics. And then once you've done that, you do need to learn a new query language, which is called PromQL in our case. And that will help you get the data that you need so you can visualize those metrics. OK, cool, you have metrics now. But you also need to set up objectives and alerts. So you have additional logic to think about, rules to write, queries to write, in order to trigger alerts based off of your objectives. It's a lot. And on top of that, Prometheus is quirky. He rides a little unicycle in the sky. And by that I mean time series data, which is what Prometheus relies on, is a different mental model than what a lot of us are used to. And on top of that, the PromQL, the query language of Prometheus, it's interacting with this time series data. And so a lot of its operators, they require knowledge of that quirkiness of time series data to get the results that you want. It's this very unsettling feeling before you've truly understood the language, where you type in a query and you're like, I have no idea if this is correct. I'm definitely looking at data. I don't know if it's the data I want. And then finally, Prometheus uses a pull-based architecture, so P-U-L-L, which is a little different than other solutions. And what I mean by this is, OK, you can imagine Animal Buttons API wants to be monitored by Prometheus. Animal Buttons API, in some world, could go over to Prometheus, knock on Prometheus's door, and be like, hey, Prometheus, I got some metrics for you. And Prometheus would be like, oh, thank you for the metrics, and take those metrics. One problem with that is that if Animal Buttons all of a sudden gets a lot of requests, it's like every time you're getting requests, Animal Buttons is going to Prometheus, knocking on the door, and saying, like, oh, I've got more metrics. And if you have a lot of services that are under a lot of load, all of a sudden, your monitoring service, Prometheus, is under a lot of load. And that could mean that increase in load crashes your monitoring, which would be bad, because you don't have a monitor for your monitor. Or maybe you do, it's turtles all the way down. At any rate, Prometheus gets around this problem by instead making it the responsibility of Prometheus to go around to your API, knock on your API's door, and be like, hey, do you have any metrics for me? And your API goes, why, yes, I do, Prometheus. Here are the metrics. And Prometheus goes, oh, thank you so much for the metrics. And then your API goes, no, thank you, Prometheus, for monitoring me. And they thank each other for a little bit longer, and then Prometheus goes to the next service that it's scraping. So I mentioned this because if you're going to implement monitoring with Prometheus, this is relevant if you use a lot of serverless stuff, because typically a batch job or a serverless job isn't alive enough or alive long enough for Prometheus to come by, knock on its door, and be like, yo, where are your metrics? There was ways around this. I have a side project that uses edge functions. I'm still able to monitor it. You just need a new component, but out of scope. OK, so bring in Prometheus's friend, autometrics. This is a library that adds metrics at the function level for things like request rate, error rate, latency. It standardizes metric naming so that it can write PromQL queries for you. Then it allows you to define objectives in code. And that means that you kind of get alerts based off of those objectives. And it's available in a bunch of different languages, but we'll focus on Python for today. So do you remember my app, animalbuttons.biz? It's the buttons, you press them, you get animals. We're going to set an objective for animalbuttons.biz. And that objective will be that animal button should work 99% of the time. Also, this is an image where the AI got confused, and it turned a rabbit into a flying rabbit, but I kept it because I thought it was cool or unsettling. I don't know, I can't decide. So we're going to use autometrics to set our objective. We're going to use autometrics-py, Python, and it just relies on a simple decorator that we will see soon enough. So you pop a decorator above your function, and then you get metrics for that function. We're also going to quickly look at a UI that's also freely available. That's called the Autometrics Explorer. It's similar to anything like Grafana or the Prometheus UI. It's just a bit more aware of the data that it's visualizing. And it's demo time. I've been tweaking this demo a lot, so I hope everything goes OK. Out of full screen mode, into Visual Studio Code. How legible is this? Is dark mode legible for everyone? OK, I see some nodding. In Python land, so I have a fast API, API for animal buttons. Here I'm just importing autometrics and some constants that will help us define objectives. And then I initialize autometrics with a version. So this will be relevant in a bit. When you track the version, it allows you to look at changes in your metrics across different versions, which can be helpful for correlating things like, oh, hey, the error rate jumped after that Boots guy started messing with the panda. Like I said, this is part of the asterisk from the beginning, but Prometheus expects to be able to knock on your door and get metrics. There's ways to not have to do this, but traditionally, you do have to define an endpoint that Prometheus can scrape. So that's what I'm doing right here. It's /metrics, and then it just returns some text about the metrics that we've been collecting. If I go down here, this is just a constant to hold my objective. I named it the high success rate objective with a 99th percentile, or 99% success rate. And if I hop down to the panda, you're going to probably see, oh yeah, OK, you can see the source of some of the slowness. But the most relevant thing is, OK, here's my routing logic from Fast API. Here's the handler itself. And then here's the decorator above the handler. So with this decorator, we say associate this function to this objective and start tracking all of those metrics we talked about. There's also a VS Code extension that's kind of nifty. So you can configure it so that when you hover over this, you get access to your metrics. I really hope this works. And we're concerned about the error rate. VS Code is concerned about opening links. And voila. So now we're in the Autometrics Explorer. And we have some data for the error rate of our panda. And actually, we can look, let's say, at the last 3 hours. And I don't know how legible. Let me see if I can zoom in a bit. So you can see here that I have two different versions, 002 and 003. If I highlight 002, I had no errors. If I highlight 003, which was released a couple of hours ago, I see the error rate jumping all of a sudden. And right here, I can see the traffic that came from this talk. Thanks for visiting my website. That was super nice of you guys. To give you an idea of the complexity of PromQL, you can also look at this query right here. So this is the query that you could use to look at this data in Prometheus. If I copied this and I went to prometheus.animalbuttons.biz, I could execute this, look at the graph, and it should roughly look, it doesn't want to do 3 hours. Look like how it did in the UI. That's about the same. And what else? We can look at the objectives. So here, I have my SLO for high success rate. SLO stands for service level objective. If I click in here, I get a chart of not only the Panda, but other additional API routes. And I can see that around a couple of hours ago, the success rate for Panda started dropping dramatically. And so the point of this objective is associated to other API routes. I can start looking at, OK, if my API is failing this 99% success rate, who's the culprit? And it's the Panda. Aside from that, I can look here and see some alerts, which are tied to objectives, as we mentioned earlier. So I could, in theory, start with an alert and then click through into the relevant objective and then find the function that is the culprit. I'm trying to think. I don't think I mentioned this earlier, but if you want to look at anything that was going on in this demo, you can click on the GitHub icon on animalbuttons.biz. That will take you to a README that has links to that Explorer, the Prometheus dashboard, the API, and the codebase for the fast API. This repo right here is for the front end. OK, that concludes demo time. Let me think. Yeah. All right. So, I'll leave you with this kind of, I don't know, call to action, mantra, whatever. The thing is, observability best practice is quite hard to implement, but it really should be accessible to people who don't have a deep observability background, and that's kind of what the autometrics library is trying to achieve, along with the tooling surrounding it. So if you're considering adopting metrics at your organization or anything like that, highly recommend looking at this library. Hello, thanks. The website is autometrics.dev. We're quite active on GitHub amongst the different implementations, always looking for contributors. And then the Fiberplane Discord, which is the company I work for, helps host the chatting about autometrics and the development of the libraries. I think I might have time for some questions. All right, excellent. That's the talk. Thank you so much for listening.
All talks need more pandas. That was the intent to nap, so perfect.
Yeah. Sorry?
Is there Prometheus as a SaaS?
Yes. Yeah, I really didn't want to make this talk an advertisement, but the company I'm working for is developing that. And then there are additional providers like Victoria Metrics is one. Yeah, people do offer it as a SaaS. Grafana also has in Grafana Cloud Prometheus. So yeah, it kind of depends on what you're currently using, things like that. Mm-hmm.
Just have time for one more question if anybody has one.
What's the most worrying logs you've ever seen come through?
The most worrying what?
The most worrying logs or metrics you've seen come through. Have you seen anything particularly worrying?
Sorry, worrying, I'm not sure if I'm...
Like if you're monitoring a service and you've seen a huge spike in something, I'm just wondering if you've ever seen...
Oh, in my life. Yeah, I don't really know. That's a good question. I can tell you when I was working on the, like I said, I'm a front end, so when I was working on the UI for that Explorer, I was kind of dogfooding it on our API. And it was kind of cool that we have a Rust backend, and just when I was building the UI, I found like a bug Just because we tied an objective to our API, I was like, oh, we're failing the objective. And then I was able to click into the objective, and I was like, this is the only function that has errors. I clicked into that function, and then I just looked into our code base, and I was like, oh, there's an error. So that was kind of nice. That's not worrying, but yeah, I don't know. It was more magical.
Fantastic. Thank you very much, Brett.
Thank you.